All right, you guys, let's start talking about polygons. Okay, so we're going to spend entire chapters on this later, entire units focusing. We're going to spend like 2 entire chapters, if not 3 entire chapters, just looking at triangles, right? Because we can cut every other polygon into triangles. But for now, we just need some basic vocab, just to get started, so that as we ask you questions, we can use the word pentagon. We can use the word irregular to give you simple practice problems in these early chapters, and we don't have to introduce each one as we go. So we're just going to kind of dump some vocab on you, ask some kind of level 1 questions, no crazy critical thinking here, but just developing that language that we'll have common so we can do cool problems in the future. Okay, so polygons. Basically, they're just a bunch of toothpicks all stuck together, right? So they're a closed shape with one inside, one outside, made of linear sides. So imagine you have a chain of toothpicks that's all jingly jangly. You throw it down, and as long as it's closed, so there's an inside and an outside, and you don't have any overlap, right? Like, so this would be 2 polygons, but it would not be 1 polygon. So as long as they don't overlap each other, and you just zigzag whatever and close the shape, that's a polygon, right? So the common things that are not polygons is it's open. So, well, if I erase that, it's going to erase the whole thing, but whatever. Let's say, so something like this, where it does not meet, that's not a polygon. Or this would be 2 polygons, but it is not 1 polygon. Or if there's like a circle, like if there's any sort of curve, that is another shape we can investigate for sure, but it's not a polygon. Polygon literally means many sides or many faces. And so, yeah, so that's it. So then we'll go further. Let's see. We name polygons by their number of sides. Concave means it is with a cave, concave. So it has an indent in it. And regular just means everything's the same. So it's all symmetrical. As you turn it around, it looks the same from any direction. That's what regular means. Okay. So polygon, as I mentioned, it's a closed 2D figure composed of line segments joined end to end. So I just made a bunch of them here on the left, right? You just any old zigzag, 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 and you meet at the end here. Whoa, it straightened it all for me. Freaking computer magic. I like that. I hand drew that, I'd have you know. And then over on the right are non-polygons, right? So I left this one open. This is a 3D drawing. This one, it intersects itself, so it's 2 separate polygons, not one, and this one both have a curve. So those are not polygons. There are other shapes. We can absolutely investigate them, but that doesn't fit this one vocab term, okay? And then we have concave. So concave, literally, I look at it as cone, a cave with a cave. And so if it has an indent where it goes back into the shape, it's concave. And every shape that does not have an indent is convex. That's it. Now you can literally like more rigorously define this in terms of geometry. So I went ahead and did that below. Another way to define it is you extend every side, every segment side to be a line. And if any one of those lines, so if I extend this side and it goes into the interior of the shape at all, that's concave. Whereas if I extend every side of this, it goes exterior of the shape. Extend, exterior. Extend, exterior. And every time I extend a convex figure sides, those extra points that I've created by that extension on the line all lie on the exterior of the shape. Whereas if I ever have an indent, which I can literally point to the indents in these figures, right? So all the ones on the left here are concave. I can extend one of the sides and it goes piercing right through the innards of this beautiful polygon, right? So these are concave on the left, convex on the right. So it's a term we will use. Okay. We name polygons just by their number of sides. The first 2 are a little funky and the rest follow the same naming pattern. So it's the Latin root for the number. Penta is 5, and then gon. And that's it for every shape. So 6 is hexa, 7 is either hepta or septa, depending what you're talking about. 8 is octa, 9 is nona, and so on and so forth. The only 2 other ones is triangle, because it's an angle, and an angle, so 3 angles. Who knows why? I want to look into the etymology of that word. I love looking at the root of words. It helps you understand the logic behind the creation. Quadrilateral, lateral means side, and quad, that comes from the Latin quadrado for square. And so this is literally just saying a square of sides, which, I mean, why'd they pick that name? Who knows? So if a polygon has 4 sides, we call it a quadrilateral. If it has 3 sides, we call it a triangle. And every other shape after that, we use the Latin root. So 5 is a pentagon, 6 hexagon, heptagon, octagon, nonagon, decagon, and dodecagon. We don't name the 11. It'd be like a, right? So this is like all the Latin roots, like Italian, like duodici. So you're literally saying 210 for 12 or 310 for 13. So it's literally just saying 2 decagon, so 210 for 12. So we'd probably call it an undecagon. I mean, we could look that up and see if it even has a name. And this would probably be like tridecagon if we wanted to add some more. It's super logical, right? We could do that. But we're only going to refer to 3 to 10. And then we have this one special 12. And then anything other than that, we just call the number gon. So if we come across a polygon with 33 sides, so polygon 33 sides, rather than looking up the like Latin root of the number 33, like treca or something, I don't know what that would be. Instead, we just call it a 33 gon. Like, oh my gosh, that's so easy. So clear, right? So 33 gon is literally a polygon with 33 sides. And that's easy. So, and we could use the variable n-gon. So a question might say, we come across this n-gon with a perimeter, and like the question could go like that, where you might have to might have to use algebra or something to solve how many sides there are. Or you might come across an 18-gon. So that's just a polygon with 18 sides. Okay? And then we have one more vocabulary term, which is really useful. Regular versus irregular. Okay? So a regular shape is just one where every side is of equal length and every interior angle has the same measure. So the big idea here is there's only one version of each shape that's regular. So a triangle, there's only one. Oh, I didn't do it below. So there's only one. Oh, I did. Yeah, right here. So there's only one regular triangle. That's an equilateral triangle. We'll investigate this later. The angles are always 60, 60, 60. No matter what size you make this, whether it's bigger or smaller, you're essentially just taking the same one and only one equilateral triangle and just just zooming it smaller or bigger. You can make it as big as a planet, although that would be really hard to make. Or you could make it as small as like an ant or an atom or something. Same thing with a regular quadrilateral. What shape is regular with 4 sides? So all 4 sides equal? All 4 angles equal? Oh, why, by golly, that's a square, right? So you got 4 right angles, you got 4 sides that are the same, and every single square is just zoomed in or zoomed out of that one. So there's only one regular 4-sided polygon, so regular quadrilateral, and it is a square. And then every shape after that's the same, right? So regular pentagon doesn't have a special name, but it's the classic pentagon you see, like if you ever played with those little wooden tiles growing up. So all the sides are the same, all the angles are the same. The nice thing about this is it has rotational symmetry. Can I rotate it? Let's see if I could do that. Let's see if I let's see, can I do this? And like, oh, I can. Rotate. So no matter which way I rotate it, if I did not draw that so well, but it would look the same every way you rotated it because it's symmetrical in every direction. Every side and angle is the same. Okay, and then a regular hexagon looks like the classic hexagon. So it looks like this, and every side is the same, and every angle is, and it just keeps going, right? And it just, as they become more and more and more, it just starts looking more like a circle. And actually, we could investigate a circle as a regular infinity-gon. And that's something that we'll revisit. And actually, all of our formulas that we investigate about polygons, we can apply to a circle as a regular infinity-gon. And that's how we could find the area of a circle, the circumference of a circle, cutting it into these infinite slices. It's just so cool, right? So we'll get there, okay? Now we can just do some problems, okay? So explain how you would find the length of a side of a regular decagon with perimeter 120. So before this lesson, you'd be like, oh my gosh, look at all that jargon. Like, what do these mean? There's so many big words, but let's break it down, okay? So we need to find the length of a side. We know it's a regular decagon. So deca, that's 10 gon. So that's 10 sides. And the 10 sides, since it's regular, are all the same. So we've got 1, 2, 3, 4, 5, 4, 10 sides. And if we add them all up, the perimeter is 120. 10 sides that are all the same added up to 120. So we just divide this by the 10 sides, and we get each side is 12. Right? So that would be it. So 12, and we put the units there. 12 centimeters per side. Oh, I drew over my thing. Oh, well, whatever. That's a 12. There we go. And then, okay, so draw a concave pentagon and explain why it's concave. Okay, so let's remember. So pentagon, that's a 5-gon. That's 5 sides. It doesn't say regular, right? Because actually, you can't have a shape be regular and concave. To have an indent in the shape, you have to have a smaller angle than these other angles. And so you can't actually have a concave and regular. Remember, there's only one regular polygon of each number, and regular pentagon always looks like that. Okay, so concave pentagon, we just need 5 sides and an indent. Well, that's really easy. We just go like this. Here's an indent. How many sides is that? 1, 2, 3, 4. Oh, there's 5. Done. Okay, and explain why it's concave. And you just go, whoop, because, well, you're right. It is concave because this indent / cave. Boom. And then, let's see, name each polygon by its number of sides, then classify it as convex or concave and regular. So we got 3 ways to classify it, right? So we got number of sides, we got convex or concave, and regular, irregular. So we have to use all 3. We have to give the full name here. Okay, so this one, boom, it's concave. And we know it's not regular. First of all, we don't make any assumptions, and it doesn't tell us if these sides are congruent, so they're not. Right? We just don't assume that. So it's not regular, and it's concave. So I'm going to call this an irregular, concave, and now we just got to count sides. I cannot count, so I apologize if I miscount. Well, I'm going to write it. Ready? 1, 2, 3, 4, 5, irregular, concave, pentagon. Okay, let's go to the next one. So we classify this by all the same things. So let's do in the same order. So is this regular? Let's check. 1, 2, 3, 4, 5, 6 sides are all the same. 1, 2, 3, 4, 5, 6 angles are all the same. So this is regular. It has to be convex then, but let's just check. This is pointed out, pointed out, pointed out. Every vertex is pointed out. There are no indents. So it is convex. Whoa, that's a weird X, okay. And then how many sides? It's got 1, 2, 3, 1, 2, 3. It's got 6. So this is a hexagon. Okay. Quadrilateral ABCD. So 4 sides. The ABCD are the points, the vertices, and they go in order. So there's an A, there's a B. Let's just double check. Okay, so it doesn't matter. So we're just going to go A, B, C, D. It doesn't matter how you draw this because it didn't tell us anything about the quadrilateral. It says the perimeter is 95. Why can't I draw? There we go. And it tells us all these sides. Here's AB, BC, CD, and AD. So we just add them up. So the first one plus the second one. I think maybe pink just hurts the eyes. I'll switch from pink, okay? So 6A plus 4 plus 5A minus 5 all adds up to 95. And let's go ahead and switch to blue. That's a nice color. Okay, so let's add up. So this is 2A minus 2. Let's just add up all the A's. So we got 3, 9, and 14, 16. So we got 16 A's. And then we'll add up all the numbers. So we got a 2 and a minus 2 cancel. And then we got a 4 and a minus 5. So that's just a negative 1 equals 95. I was doing the next step. So add 1, add 1. We got 16A is 96. Divide by 16. And we get A is 6. Now, always see what it's asking. Let's go back and say, find the length of each side. Okay, well then you just plug the 6 back in. See what that is. That'd be 20. Plug this in. That'd be 2 times 5 is 10. We plug that back in. We get 36. That's 40. Whoa, so we got 20. We got 10. We got 40. This is already 70. The last one better be 25. So we plug this in, and that's 30 minus 5 is 25. Check. Add them all up. 95. Double check our answer. We're good. Okay. Name each polygon by its number of sides, same as before, okay? So this is a not regular, so irregular. There is no cave, so it is convex. And there's 4 sides, so it is a quadrilateral. This one, all the sides are the same, and the angle, so it's regular. Again, it's convex, there's no indents. And there's the 8, it's a stop sign, so it's an octagon. Okay, this one over here, every side is the same, and look, every angle is the same, except for these angles. Ooh, so it's got a lot of symmetry, but it is not regular. Another giveaway is you can't have an indent in a regular polygon. Okay, so this is an irregular. And now actually, we're going to talk about this later. It is actually equilateral. Lateral means side. Equa meaning they're equal. So it is equilateral. All the sides are the same, but it is not equiangular. Again, these are vocab words we'll get to. So all the angles aren't equal, but all the sides are. So this is an equilateral polygon. But anyways, I digress. And so there is a cave, so it's concave. And then how many sides? Okay, so 2, 4, 6, 8, 10 sides. So this is a decagon. Okay, traffic signs. Identify the shape of each. So let's just assume these are perfect vertices with straight edges, because otherwise they're not polygons. So this is 5 sides. So it's again, we can talk about this. So it's an irregular convex pentagon. This, I mean, we can't say the first one. So is it regular? I don't know. It kind of looks like a square. We can't really answer that, but we can answer it is convex, and it is a quadrilateral. Again, is this one regular? I don't know, but it is a convex triangle. Okay, and this one over here is not regular. Definitely it has an indent, so it's an irregular concave, because it has indents. And 3. I almost made a mistake there. So 1, 2, 3 on each of these. So 3, 6, 9, 12. So we have a dodecagon. Perfect. Okay, let's see what we got after that. Oh, that was it. Okay, you guys, I hope that helps just with the basic vocab of polygons. Again, we are going to spend entire chapters investigating 3-sided figures. Then we'll investigate 4-sided. And then we'll investigate all sorts of things after that. All right, guys, have fun.